Yo, 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 extended math students, it's Mrs. Frame, and I am here to help you study for your first big test. Get out your notes, get out your review sheet. We're going to go over a few of the problems to prepare for tomorrow's test. Ready? Here we go. I'm going to go ahead and start with number 4. So we're looking at number 4, and we've got to follow the rules. So the first thing I like to do is split my problem into 2 sides. So I'm going to work left and right to get each side as simple as I can before I start taking numbers and crossing the border with them. So let's start with the left-hand side. We always, first step, distribute what we have to get rid of parentheses. So we have 5 times x minus 5 times 1 plus 2 equals, and there's nothing for us to do on this side. Now, as I said, before I start moving numbers across that border, I need to simplify as much as I can. On the right side, I have 2 numbers that I can put together. So I'm going to do that. Negative 5 plus 2 is negative 3. And here I have this problem. 5x minus 3 equals 5x minus 13. Now I gotta say that's already making me feel like something might be a little wrong. Let's continue working. Let's move our x's to the same side, put our constants on the other in our quest to get the x isolated. So we're going to move the 5x to the right. When we do the x's this direction, let's take the constant to the right. So we're going to add 3. Now, here's a problem. 5x minus 5x is 0. There's no more x. And negative 13 plus 3 is negative 10. And I have what we call a false statement. That means, folks, that there is not a number in the world that I can put in this place. And so our answer is, there is no solution. Now remember that if this happens tomorrow on the test, but for some reason we get something like 5x minus 3 equals 5x minus 3, notice that they're identical statements, and I move the 5x across the border to be with this 5x and cancel it out, and I take this negative 3 and I put it on the other side and I cancel that out. I get the statement 0 equals 0. Guess what, guys? That's true. And when that happens, remember this, infinite solutions. I can pick any number on the number line and plug it in for x, and it's going to be true. So don't forget these 2 special circumstances. True means infinite solutions. False means no solution. Okay, moving on. Let's take a look at number 7. We also have fraction problems, if you recall. I'm going to scooch that down a little bit. So remember that when we're solving the problems with fractions, that the best thing to do is always first look to see if you have to distribute anything. There's no parentheses, so we don't have to worry about that. The second thing we do is we look for the least common denominator so that we can clear the fraction and get it gone. So I'm looking at 7 and 3, and I can't make 3 7, and I can't make 7 3. So I'm looking for the first number they both can become when we skip count. 7 times 3 is 21, and that's the first number they both can be when we skip count. So we're going to call the least common denominator 21. So what we're going to do, folks, is we're going to take and we're going to multiply each part of our problem by 21. Every single term gets the 21. So that first fraction gets it, the second fraction gets it, and the 2 over here gets it. So we're going to be using the least common denominator. Now what we're going to do is we're going to cross cancel. 7 goes into 21 3 times, and it goes into itself 1 time. 3 goes into 21 7 times. Alright, and we don't cancel anything over here. Alright, so now let's go ahead and write what we have now. We have 3 times 2x, we don't need to put a 1 under it, minus 7 times the quantity x plus 2 equals 21 times 2. Now we're going to distribute, get rid of our parentheses. So here we get 6x. Distributing here and here, you get negative 7x minus 14 equals 42. Then we're going to draw our border. What's over here that we can combine? Our x's. So 6x minus 7x is negative 1x. Minus 14 equals 42. Alright, so we're in our quest to isolate the x, we've got to move numbers across the border. So let's disguise this negative 14 as a positive 14 because we want him to go, we don't want him over here, we want him to zero out. So we're going to add 14 to both sides. And we'll bring everything else down. Negative 1x equals 56. Now that x is still not isolated. That negative 1 wants to cross over here and be with the other number. So we're going to do the inverse, disguise it. Instead of multiplying by negative 1, we're going to divide by negative 1. And that leaves us with x equals negative 56. Now you can plug it in and check it if you want. That is up to you on an exam. Okay? Ready to move on. We have one more problem here, and I noticed that a lot of people in class were struggling with this one. And it wasn't because of this part. It was this part over here. So let's first draw our border and start simplifying on this side. Let's distribute. So we get 15x minus 27 plus 2x equals 8x minus 5. It's all coming down. It's this minus that you have to distribute. Okay, so what we're going to do is treat that as a negative 1 because that is one whole group right there. So you're going to distribute a negative 1 to both of these terms, and that's negative 1x minus 7, negative times positive. Now, on this side of the equation, we have two x's here, so we need to put them together. 15x plus 2x minus 27, and keep working that down. That's 17x minus 27. And remember, guys, that you take the little the sign in front of the number when you move it. So that's why I put the negative on the 27 and the positive on the 2x, or the minus and the plus. Over here on this side, I'm going to rearrange as well. 8x minus 1x minus 5 minus 7, and I'm going to combine these two. 8 minus 1 is 7x, negative 5 minus 7, negative 12. Alright, so now I've got both sides as simple as I can make them. I'm going to bring the x to the left and take the constant to the right. So let's disguise that positive 7x as a negative 7x and subtract, and he's going to go away. Since we're bringing the x's to the right, let's take the constant to the left, disguise this negative 27 as a positive 27, take him across the border. Here we go. Cross him out. He's no longer on this side of the border. He's a 0. Subtract and you get 10x equals positive 15. You have your calculators, no excuses. Now this 10 wants to join the 15, so we have to disguise it. It says multiply, so let's divide so we can disguise and cross the border. Here we go. X equals 15 tenths. But that's not good enough, folks. Whenever you have a fraction, you have to make sure you can't simplify. They have in common a 5, so we're going to reduce it to x equals 3 halves. Alright, here we go. Next question. The next question we have, guys, is an inequality. Now remember that solving an inequality is exactly the same as solving an equation. One moment, I'm going to pause and close the door. Sorry guys, it was too loud out in that hallway. Alright, so again, going back to what I was saying. When we solve an inequality, it's exactly the same as solving an equation. The process is the same. You treat the inequality symbol just like you do the equal sign. You just have to remember that in one situation, you do have to reverse the symbol. And I don't think that situation is going to occur in this time, but I think it occurs in my next problem. So let's go with the same process. We have to distribute. So I'm going to draw my border right now, and I'm going to distribute 3x plus 15 minus 13 is less than or equal to 2x. Again, we have to simplify things on each side of the border, and we have two numbers that go together. Those two. 3x plus 15 minus 13 is 2 is less than or equal to 2x. Now, We like for you to bring the x's to the left so that you can use your inequality sign as an arrow to tell you how to draw your graph or write your interval notation. So we're going to go ahead and bring this 2x to this side. And since we're bringing the 2x over here, we want to take the 2 and put it over here, so we're going to go ahead and subtract it. And we're basically subtracting it from nothing, so it's going to be a minus 2. So we cancel that out and cancel that out. And here what we have left is 1x, how nice, is less than or equal to a negative 2. Now, there you have it, folks. I believe that you're supposed to write your answers in interval notation, but let's go ahead and graph it first, and then we can write it in interval notation. So since it's pointing to the left, we know that we're going to be coming this direction to negative infinity, and negative 2 is going to be our boundary. So I'm going to go ahead and put my negative 2 there. Because it says negative 2 is less than or equal to, on my negative 2 I'm going to use a bracket. Remember, the black bracket says it's equal to this number as well. Okay, and then this is pointing to the left. And so that's what the graph would look like. I believe you're supposed to, like I said, write it in interval notation. So to write it in interval notation, remember that you start with the smallest value, which is way over here in negative infinity. And you stop at your boundary, which is negative 2. And you're going to use a bracket, again because of that equal sign on your inequality. Okay, so there you have both responses, actually all three responses to this inequality. Okay, and all you have to do to check it is pick a number that's less than negative 2. Like, for example, you could pick negative 5 and plug it in right there and plug it in right there, and it should work. So if you did 3 times a negative 5 plus 5 minus 13 less than or equal to 2 times negative 5, which is a negative 10. Hopefully I'm not off the screen. And then you follow order of operations. You get 3 times 0 minus 13 is less than or equal to negative 10. 3 times 0 is 0. Negative 13 less than or equal to negative 10. This is true. So we know that we scooped up the right side of your boundary, which was the left side. Okay, moving on to number 16. Alright, so here we have another problem that you have to solve. Give me a second. I'm going to check to make sure I copied it down right when yes, I did. Alright, so we're going to solve this problem. Alright, so here again is our border. We're looking at the left hand side and we are trying to simplify, so we must distribute. So we get negative 4 minus 24x minus 3x is greater than or equal to negative 139. Again, we want to reorganize and simplify. So I'm going to put my x's in first. Negative 24x minus 3x minus 4 is greater than or equal to negative 139. And then I'm going to combine my x's. They're on the same side, so I'm just going to do what it says. Negative 27x minus 4 is greater than or equal to negative 139. Now we're going to start moving numbers to we only have x's on this side, so that's nice. Let's take the numbers over there. So disguising the 4, canceling them out, yet negative 27 is x is greater than or equal to negative 135. Subtract because their signs are different. Now we're dividing by a negative. Remember what you do when we divide by a negative and we're working on an inequality? Yep, we reverse the symbol. That's the only thing that's different when you're solving an inequality. Okay, and the answer to this is, hang on, I wrote it down on my paper, 5. There are 5 27s in 135. Negative divided by negative is positive. Okay, your interval notation, or let's do the graph. The graph says we're pointing to negative infinity, so our boundary is going to come over here. We're going to use a bracket because of the equal sign pointing to the left. Your interval notation from negative infinity to 5, close that bracket. Okay, and there you have that. Alright, so the last two problems I put on here were your word problems. Okay, so the first one here, you have a question like this tomorrow on the test. Is the sum of 3 consecutive, meaning in a row, odd numbers? Okay, so there are odd numbers in a row, like 1, 3, and 5. Or if we're in negative land, -7, -5, -3. Consecutive odd numbers. Now, what we're doing is we're adding 3 consecutive numbers and getting the word is means equals to -279. So we have to remember that when we're doing consecutive numbers, what we don't know is what the first number is. So we do the first number plus the second number plus the third number is equal to -279. The thing is, we don't know anything about the first number at all. We have no idea what it is. We do know a little bit about the second number. The second number is 2 bigger than the first number because odd numbers are 2 apart. So if this was 1, this would be 1 plus 2, 3. The third number being 4 bigger. If this is 1, 1 plus 4 is 5. 1, 3, 5. Okay, so remember that that's how we talk about consecutive odd numbers. Okay, and then we're going to do combining like terms. So you're going to distribute that positive 1 there. Okay, so that's pretty easy. You have x plus 2 plus x plus 4. And again, drawing your border, combining your like terms, you have 3 x's, 1, 2, 3. 2 plus 4 is 6, equals -279. We're going to subtract 6 and put it over here on this side. Canceling it out here, we get 3x equals, and then we're going to add those together, -285. Then we divide by positive 3, and divide by 3 to get that x isolated, and we get the answer. X is equal to a -95. So that's our first number up here, a -95. So what we have to do to find our other two numbers, if x is equal to -95, then we have to do x plus 2 to get our next number. So -95 plus 2 is -93. And then to get the third number, we're doing plus 4. So plus 4 would give us -91. So the three numbers we were looking for were -95, -93, and -91. And if you were to add them all together, you would see in your calculator that they add up to 279. Okay, or -279. All right, last question is this one. The perimeter of this rectangle is 38 inches. If the length is twice the width, decreased by 2, find the dimensions of the rectangle. Okay, so let's go back and get comfortable with this problem. It says we have the perimeter of a rectangle is 38. And perimeter means we're adding up all of the outside. So let me write the formula for a perimeter of a rectangle. Perimeter is equal to basically side 1 plus side 2 plus side 3 plus side 4. I mean, that's the basics. It's not the, the formula is perimeter equals 2L plus 2W. But let's just keep it as simple as we can. All right? Now, in our first sentence, we got the perimeter is 38. So we can replace P, perimeter, with the number 38. Now, let's go mark up our model here. It says, if the length is twice the width, decreased by 2, I'm looking for the thing I don't know anything about. It's telling me a lot about the length. It's telling me the length is twice the width, decreased by 2. But it's not telling me anything about what the width is. I don't know what the width is. So that becomes my thing that's unknown. So I name it X because I don't know anything about it. Now, we go back and look at how we compare the length to the width. It says the length is twice, 2 times the width. So 2 times the width looks like this. 2 times our unknown. Decreased by 2 means we have to subtract 2. So we would label those there. Then all we have to do with our model and our numbers is plug them into our formula that we wrote. So x plus 2x minus 2 plus 2x minus 2. And then all we have to do is combine our like terms. So we get 38 equals 1, 2, 3, 4, 5, 6 x's. 6x. And minus 2 is negative 4. Okay? And then we have to solve our equation. So our x is on the left for once. Let's go ahead and put the constant on the right. So we're going to add 4 and add 4. And then I'm going to have to come over here with my work. We get 42 equals 6x. And we're moving the 6 to the other side. So we're going to divide by 6 and get x equals, guess what? 7. So we come up here and we now know that our width is 7. Now let's check it out. If our width is 7, we should be able to, that should be a 7, sorry about that. We should be able to plug it in here next to the 2 and find out the length of our, find out the length of our length. So we get 14 minus 2 is 12. Okay, well let's make sure this all does really add up to 38 for our check. We have 7 plus 12 plus 12. Add them all up. So that's 14, 15, 16, 17, 18. Carry the 1. 1, 2, 3, 38. So let's answer the question. Our dimensions of our rectangle are 7 inches by 12 inches. And there you have it. Hopefully this helps for you to study for your test. Make sure you remember what to do with your fractions and how to clear them, and you practice solving equations. Have a good evening and best of luck tomorrow.